Now let's move on to a new chapter, chapter 8 on probability. And this will be easier chapter. And if you are struggling with the last section or two in chapter 7, don't worry too much about it. After all, things will get easier in this chapter. So in chapter 8, let's firstly talk about the idea of the probability. In everyday language, we use this word probability to describe the situations for everyday events that do not occur with certainty. So it is possible that something would occur. It is also possible that this thing will not occur. You can talk about what's the probability that it will rain tomorrow, or you can talk about what's the probability that electric appliance is defective, or you can even think big about talk about the probability of war. And in chapter 6, we also indirectly introduce the notion of probability in a more technical sense, and we call the population frequencies. This frequency approach is usually associated with events that can be repeated again and again, and under pretty much the same conditions. Notice that this is not quite the same thing as for example, we talk about the probability of war, because we can't really do this experiment again and again. Every year, every day is different. And now let's take a look at what's the goals of studying probability. First of all, we're going to learn how to compute the probability of complex events formed from two or more elementary events. And then we'll solidify the notion of the population and also the probability of distribution of numbers generated by samples. And then we'll introduce properties of distributions that we use later. And then when the problems become too complex, we can approximate probabilities to get the approximation. So what do we mean by sample space? The sample space is basically the list of all the possible outcomes and for probability experiments. And well, it really depends on our knowledge and interest. For example, if you know what a standard 52 card deck of playing card is, we can draw a card from the 52 card deck, and we can talk about different sample spaces. For example, it could be a list of 52 elements, just 52 cards. It could also be just the 2 elements, and one is red, one is black, depends on what our interest and knowledge is. Let's think about college lectures. Suppose a college lecture consists of 2 lectures per week, meet on separate days among Monday, Tuesday, Wednesday, Thursday, and Friday. So what would be the sample space of possible times a student might choose? Well, here, if a lecture meets twice a week, it could be Monday, Tuesday, and Monday, Wednesday, and Monday, Thursday. I'll use R for Thursday, and Monday, Friday. It could also be Tuesday, Wednesday, Tuesday, Thursday, and Tuesday, Friday, or Wednesday, Thursday, Wednesday, Friday, or even Thursday, Friday. And are they equally likely? The answer is no. Some of them are likely, some of them are quite possible. Like Tuesday, Thursday is a very common arrangement. You probably are taking some Tuesday and Thursday class right now, unless it's right now in the summer. And or Monday, Wednesday is also possible, but Thursday, Friday is extremely unlikely, if not impossible. So those are examples of probability sample spaces that the things would occur with different probabilities. And for this course, for our purposes, we'll focus on the case that the elementary events are of the same probability, or in other words, they have the same chance of happening. So for example, when you draw a card from the standard 52 card deck of playing cards, we assume that each of the 52 cards has the equal chance of being drawn. So if I ask you, hey, what's the probability of drawing an ace? The answer is 4 over 52 or 1 over 13. That's because there are 52 cards to draw from, and 4 of them are aces. On the other hand, if you talk about what's the probability of not drawing an ace, the answer is 48 over 52 or 12 over 13. And in general, the probability of event A, assuming that this experiment consists of outcomes that are equally likely, and we can assign to an event A this probability, and we'll use this fraction. The numerator is the number of outcomes favorable to an event A, or in other words, a number of elementaries in this event. And then the denominator is the total number of outcomes of all these experiments. So for example, if we draw a card from the well-shuffled deck of playing cards, 52 cards, what is the probability that it is a heart? The answer is that's 13 over 52, or 1/4, because there are 13 hearts out of 52 cards. And now the next question is, what is the chance? Or, by the way, the chance is another word for probability, just synonym for probability. What is the chance the Joker is drawn from this 52 card pack of this example? The answer is that's 0, because there's no Joker in this standard 52 card pack. And also, what is the chance that we do not draw a Joker? The answer would be exactly 1, because that's 52 cards out of 52. All of them are non-Jokers. So the answer would be, the first question is 0. The second one is 1. Now let's think about 2 coins. Suppose you toss 2 coins separately and find the probability that both come with heads, and also finds the probability that exactly one comes to heads. So when you just toss two coins, and there are altogether 4 possible outcomes that are equally likely. One is head followed by a head. You can also get head followed by a tail, or tail head and 2 tails. Those 4 are equally likely. So if you look at the sample space, you can think about the sample space consists of 4 elements equal. It's equal probability, and then the probability of drawing our 2 heads would be 1 out of 4. So the answer to the first probability is 1/4, and the second one is actually 1/2. The reason is because there are two possible scenarios for exactly 1 head. It's head followed by a tail, or tail followed by a head. So in this case, we have 2 cases out of 4. So the answer is 2 divided by 4, or 1/2. Very good. So this is the basics about probability, and we'll talk about independent events in the next video. Thank you very much for watching. I will see you in the next video.